Hello and welcome to another geometry video. This one's actually more of an algebra video, but it has a geometric application to it. So we're going to learn how to complete the square from quadratic equations. Okay, so for circles, what it does is it allows us to take a standard form equation where it's an x squared xy number equals 0 form and write it in center radius form, something that's much more useful for us geometers to know the center and the radius of a circle. Okay, so your goal is to take that standard form equation and create some perfect square quadratics, okay, that are nice and easy to factor. The factor to something that is useful for us in geometry. Okay, and it's very procedure based, and there's 4 steps, or 3 or 4 steps depending on who your teacher is, maybe even 5, to the process of completing the square. But what we want to do is make a perfect square factor. Okay, so to get started, let's go through the process. So here we have ourselves just a regular old quadratic. Okay, and notice x squared plus 4x plus 11 is not a perfect square. It's not even factorable. There are no numbers that multiply to give you 11 that also add to 4. That are nice and pretty. So what we want to do is make this part, okay, use this, our 2 variables, and make it into a perfect square factor, okay, a perfect square quadratic. So in other words, numbers that will multiply or add to give you 4. Okay, so some teachers like to teach you to do this. You need to subtract the 11 from both sides to get your variables by themselves. Okay, so x squared plus 4x plus something. This is the square that we're going to be able to put in there on our own. And remember the rules of algebra, what you add to one side of the equation, you also have to add to the other side of the equation, okay, in order to balance it out so that you're not actually changing the problem. Okay, it balances. What you add here, you also have to add there, so you have a balanced equation. Now the number that goes in here is a very special number. I call it the square. Okay, and what the square is half of that middle number. So if this is a squared, ax squared plus bx plus c, okay, this is your b value. It's half of the b value squared. Okay, and that's what we're going to do to make this into a perfect square quadratic. So for 4, what is our b value? That's the question. So what's half of 4? Half of 4 is 2. So 4 divided by 2 squared. So 4 divided by 2 is 2. 2 squared looks like it goes back to 4. Again, this is the only number that does that, by the way. So our perfect square, our square is 4, and we will add it to both sides. Because what you do to here, you have to do to there. Okay, so what we've done is we have made this into a perfect square quadratic. Okay, so you can think about it. What numbers multiply to give you 4 and add to give 4? Okay, multiply to give you 4, add to give 4, because we want to factor this. Those numbers are, of course, 2 and 2. So the factors of this are x plus 2 and x plus 2. And now, of course, as mathematicians, we don't write it repetitively like this. We like to use our standard nomenclature there and write x plus 2 quantities squared. And over here, negative 11 plus 4 is negative 7. Okay, so this is what we're going for when we complete the square. We want to have something that looks like this. Some quadratic that becomes factorable so that we can have it in this form, because this is so much more useful to us geometers than this equation up here. Okay, much more useful. So those are the procedures we'll go through again, don't worry, in this next example right here. Okay, so complete the square, make this end up as something squared equals, of course, something else. Okay, so step 1 is to get the number on the other side so that we can complete the square with these 2 variables. Okay, we're going to make this into a perfect square quadratic. So y squared minus 14y plus something, right? And it's the something that's the important part. is equal to 30 plus something else. Okay, and this number over here will be important to us in geometry. In algebra, this is going to be the y-coordinate of your vertex if you're doing algebra 2 and completing the square. But for geometry, this is going to be our radius when we start square rooting. But for now, it's just a number. So the number that goes in the box, remember, that's half of the middle term. So negative 14 divided by 2 squared. Okay? Negative 14 divided by 2 is negative 7. Negative 7 squared is 49. Sorry, that's the bell. That's the end of the day, actually, for me right now. So I'm going to finish the video and then go home. So 49, that's the number that goes in the box. Half of the b value squared. Okay, now this is our perfect square trinomial, our perfect square quadratic. Okay, so the question is, or the question becomes, what numbers multiply to give us 49 and add to give negative 14? Because these are going to be the factors that are going to here. And that's negative 7 and negative 7. Negative 7 times negative 7 is 49. Negative 7 plus negative 7 is negative 14. Okay, so rather than writing y minus 7 and y minus 7, your actual factors, we as mathematicians write simply y minus 7 squared. And on this side, 30 plus 49 will equal 79, which is important later. But what we want to do now is just the process. Okay, so we have taken this quadratic equation up here and wrote it, or rather written it, we have written it in a more useful manner. Okay, algebraically it's still the same. You plug in a y value here, you plug in a y value there, you're still going to get the same output. But this is much more useful to us as geometers, and sometimes if you want to find the vertex of a quadratic or of a parabola, this is of course a much more useful formula as well. So let's move on to the geometry here. Okay, notice there are two variables in your equation, x squared plus y squared plus 6x minus 10y plus 4 equals 0. Okay, this is standard form for a polynomial of two variables. Highest power first and then lowest power goes all the way down. Okay, so for us, the first step is to move the numbers to the other side. So minus 4, minus 4. Okay, which gives us this equation, x squared plus y squared plus 6x minus 10y equals negative 4. Okay, just take the numbers, whatever non-variables you have, put them all together on the other side of your equal sign. Okay, and now get the like variables together. So we're going to set up our equation. So 6x comes after the x squared plus y squared minus 10y, okay, equals negative 4. So we're doing this so that we can get it into a form that we as geometers like, okay, the center radius form. Because you know you need parentheses and squares when you have the circle center equation. Okay, so you get the number over there and then you get your variables together. Because we're going to complete the square on two different variables at the same time. Okay, so here we have it. So x squared plus 6x plus something, okay, plus y squared minus 10y plus something equals this. So I need to add both of these boxes to the other side. Let's go to red. So red's my first thing, sorry, plus whatever the red box was, plus whatever this blue box happens to be. Okay, so I add the red box to both sides, I add the blue box to both sides, everything is balanced. Now, remember, what goes in this number? What number goes in here? Okay, so the number that goes in here is half of 6 squared. Half of 6 squared is 3 squared, which is 9. So I'm going to add 9 to here. Okay, 9 to the x stuff. And then to the y stuff. So half of negative 10 squared is -5 squared, which is 25. So I'm going to add 25 in each of these boxes. Okay, so now what I have made, of course, is my perfect square trinomial, my quadratic that is nicely factorable. These three terms now, what numbers multiply to give us 9 and add to give 6? Are 3 and 3. So these three things now factor to x plus 3 squared. Very useful for us in geometry. Now these three things over here, y squared minus 10y plus 25, okay, what numbers multiply to give you 25 and add to give -10? -5 and -5. This now becomes y minus 5 quantity squared. And over here, let's see what I have. -4 and 9 is 5. 5 and 25 is 30. Okay. Now this is a much more useful formula for us in geometry. Okay, this is our center radius form, we call it, or I call it rather. I don't know about we, but so x minus h squared plus y minus k squared equals r squared. So now that we have it in a useful form, we can analyze it. So this equation, this circle, has a center at -3, 5. Okay, because what number plus 3 equals 0? Well, -3, so the answer is -3. What number minus 5 equals 0? +5. So we have a center at -3, 5, and a radius of the square root of 30. Which, yes, is in between 5 and 6, but this is a much more useful, much more perfect answer. So I let my kids leave it as a square root of 30. Okay. So for geometry, much more useful in this form rather than given your standard equation. Okay, but we take your standard equation and you write it in something useful using completing the square. Okay, the method known as completing the square. Okay, so let's do a couple more. Identify the center and radius. We'll do 2 of them just to get good at it. So identify the center and radius of this equation. So we need to get this equation from standard form into center radius form. Okay, so step 1, get rid of the 14. Okay, step 2, get your x stuff together. Oh, it looks like a minus 2x. Let me erase this. Minus 2x. Okay, plus something. I know I'm going to have to do this already, so plus something. Plus something pink. Something over here. Change colors. Plus y squared plus 8y plus something. Okay, I got to complete the square with the x stuff and with the y stuff. Okay, and over here I add it to both sides. So here's my 14, rather, not 4, sorry. 14 plus whatever the pink box is plus whatever the purple box is. So let's see what these are going to be. So what goes in the box? Half of -2 squared. So half of -2 is -1. -1 squared is 1. So I'm going to add 1 to both sides because of my pink box. And let's see, half of 8 squared. Half of 8 is 4. 4 squared is 16. So I'm adding 16 to both sides because of my pink box. Okay, so now let's factor these three things. What numbers multiply to give you 1 and add to give -2? Well, that's -1 and -1. So this one factors to x minus 1 squared. The purple things factor to what numbers multiply to give you 16 and add to give 8. That would be 4. So y plus 4 quantity squared. And on the right side, 14 plus 16 is 30. 31. Okay. 14 and 16 is 30 plus 1 is 31. So I can now analyze this. My center is at the point 1, minus 4. And my radius is the square root of 31 units long. Okay, so from an equation, You get the number over, okay, get your x stuff together, get your y stuff together, complete your square so that we have it in a useful form, okay, before you can find the center and the radius. Okay, one more time with this equation. Remember, step number 1, get rid of this number, so plus 11. Okay, get your x things together. So x squared plus 12x plus a box. I know I'm going to need a box, so I put it in here. Okay, now we do the same thing with our y's. Y squared plus 4y plus a box. Your square equals, on this side, our 11 plus your pink box plus your purple box. In my case, purple box. You can probably just use pen or pencil or whatever it is that you have, but if you color code it, maybe you can see exactly what you're doing a little bit better. I don't know. So, half of 12, the number that goes in the box. Half of 12 squared. So half of 12 is 6. 6 squared is 36. So I'm going to add 36 to both sides because of the pink square. And half of 4 divided by half of 4 squared. Half of 4 is 2. 2 squared is 4. So I'm adding 4 to both sides here. Okay. So now that I've gotten all my things done, I have a perfect square, quadratic. What numbers multiply to give you 36 and add to give 12? That's 6 and 6. And the purple, what numbers multiply to give you 4 and add to give 4? That's 2. Okay, it's also always going to be half of this term, by the way. So half of 12 is 6, half of 4 is 2. Back over here on this side, half of negative 2 is negative 1. Half of positive 8 is positive 4. Okay, so if you can't think about the factors, they're always going to be half of this b term, whatever sign. If this is a plus, that's a plus. If this is a minus, that's a minus. Okay, equals, let's see here, 36 and 4 is 40. 40 plus 11 is 51. So analyzing, this circle has a center at negative 6, negative 2. Those are the coordinates of the center. And it has a radius of square root of 51 units long. Okay, so completing the square is a very handy, useful tool to have in your belt when you are trying to take something that is kind of jumbled and write it in a useful form. Okay, especially for geometry, when we're doing circles, you can find its center by completing the square with each of your variables that needs to be completed with. Okay, for algebra, you can do this to find the center of circles or conic sections, okay, like parabola and hyperbola, and ellipses. They can tell you, if you do it right, the major and the minor foci, and where you can find all your thing about ellipses and hyperbola as well by completing the square. So hopefully this has been useful, and good luck on your problem.